Alright guys, today's goal: the learner will understand graphs of rational functions. What you'll learn about rational functions, transformations of reciprocal functions, and limits and the asymptotes, and analyzing graphs of the rational function. And why rational functions are used in calculus and scientific applications such as inverse proportions. Rational function. It says, let f and g be a polynomial functions where g of x cannot equal 0. Why can g of x cannot equal 0? Because it's in the... and this is what I was looking for. Because g of x is in the denominator, guys. You can't ever divide by 0. So what they're talking about is we've seen problems like this. Well, here, let's use... So there it is. See where, in this case, f of x is 3x plus 2. G of x is x plus 2. And what do you know x cannot equal? Negative 2. Okay? It says, example of finding the domain of a rational function. Find the domain of f and use limits to describe the behavior values of x not in its domain. Okay. So we learned end behavior talking about the limit, but you'll see what's going on here in a minute. Okay. So the domain, well, what can't happen? X plus 2 cannot equal 0, so x cannot equal negative 2. So, remember how for end behavior we said as x goes to positive infinity, as x goes to negative infinity, we want to see what is it doing when we approach this. So you say the limit of f of x as x approaches negative 2 from the left, what's going on? The limit as x approaches negative 2 from the right, what's going on? Okay? So the domain is, well, we could use interval notation, but it doesn't say to, so all real numbers, but x cannot equal negative 2. So go ahead and put this in your graphing calculator and take a look at the graph. And if not, just wait a minute. But what you'll see, as the function is approaching, what this means is, as x is approaching negative 2 from the left side, where is the y value heading? Negative infinity. As it's approaching it from the right side, where is it heading? Positive infinity. Okay? So let's take a look at the graph and let's see if we got the domain and everything right here. Yep. So here is that vertical asymptote. What I'm saying, what this one is saying, see how it says negative 2 from the left? Look what's going on. As I approach negative 2 from the left, where's the y value going? It's going down to negative infinity. As I approach it from the right, where is it going? Up to positive infinity. Okay? Alright. So, graph of a rational function. This is just saying a function of some degree divided by a function of some degree. Okay? It says if n is less than m. So look, what that means is, right here, n is this exponent. If the denominator has a higher degree, the end behavior of a horizontal asymptote is y equals 0. So, an example of that. This is for n less than m. (3x divided by x squared plus 2). The top of the degree is the top of the numerator, or the degree of the numerator is 1, the degree of the denominator is 2. See how n is less than m? Okay? And if you check by plugging it into your calculator to look at the graph, you'll see instead of it approaching positive or negative infinity, it approaches 0. Okay? So it says if n equals m. So if n equals m, we have 3x minus 5 over 2x plus 3. It says if n equals m, the horizontal asymptote is y equals a divided by n, so the lead coefficient of each. That's what that's saying. So the horizontal asymptote here would equal 3 over 2. So again, check in your calculator, and you should see it stopping at 1.5, a horizontal asymptote. Okay, and that's the end behavior. As x approaches positive infinity, it equals y is approaching 1.5. As it goes negative infinity, 1.5. Okay. If n is greater than m, the end behavior of the asymptote is a quotient polynomial function. So basically, these are multiple functions. It's not horizontal. It's going to be angling up or down. So that's where you have to be able to look at it and see, is it going to positive infinity or negative infinity, okay? And that would be something like 3x squared divided by the quantity x minus 1. So, okay? So for this one, the end behavior would be the limit of f of x as it approaches. Put it into your calculator. You might have to zoom out to see both. Yep. So this would be the limit as x goes to negative infinity, f of x goes to negative infinity. And then the limit as x goes to positive infinity, f of x also goes to positive infinity. Because when I looked at the graph, it was this and this. See, so that asymptote that they're talking about is not horizontal. The one they were talking about is right here. Okay? There still would have been the vertical at x equals 1, but, okay? So, the vertical asymptotes, we've learned they occur when the denominator is 0. X-intercepts, plug in 0 for y, solve for x, or the zeros of the numerator. Y-intercepts, plug in 0 for x, solve for y. O's should not be hard. So find the asymptotes of the function. Well, let's do the vertical first. Set the denominator equal to 0. Solve. So there's the vertical, the horizontal. Alright, well, the degree is even. So n equals m. So you could either multiply it all out or realize these are in intercept form. So the lead coefficient on the top is 2. Lead coefficient at the bottom is 1. So your horizontal is at y equals 2. Okay. Now you could have multiplied it all out, because if you did, the top would have been 2 times x squared minus 9. And the bottom would have been x squared plus 6x plus 5. See how degree of 2, 2, 1. That's how I got that. So we know our graph is going to look something like this. So go to -1, go to 1, 2, 3, 4, -5, and 2. Okay. So let's take a look at the graph in the calculator. And it looks, a quick sketch, it looks something like this. So if you look at that, now if we looked at this and I said, what is the limit as x approaches negative infinity of f of x? I'm following this. What is it approaching? Well, what's the horizontal asymptote there? 2. The limit as x approaches positive infinity of f of x. Well, what is this one approaching here? 2. Now notice in the middle, it crossed the horizontal asymptote. That's okay. Horizontal does not mean it's never going to cross it. It's just telling you what the end behavior is. Okay? So yeah, we got those right. So now it says find the asymptotes and intercepts and then graph it. Okay. So the asymptotes, the vertical, x equals 2, x equals -3. The horizontal is y equals 0, because the degree of the top is 1, the degree of the bottom of the 2. Remember, if the degree of the bottom is larger, it's 0. Intercepts. Set y equal to 0, solve. But here's the thing, if I multiply, what's 0 times anything? 0, so that's gone. So you just have x minus 1 equals 0. So x equals 1. There's the x-intercept. The y-intercept, plug in 0 for x, solve for y. Negative 1 times negative 2 plus 3, so negative or positive 1/6. Okay, so horizontal right there. The vertical are at 2. And negative 3. Now, put this into your calculator. I can graph a couple points here. So I know the x-intercept was 1. And the y-intercept was positive 1/6. And then if you look at the graph and then hit table, when I get to negative 2, it gives me 0.75. So it's starting to go up. And this side, when we saw it's starting to go down, so this one was going and then it came from way up here and down to 0. Okay, so there's our graph. Yep, here we go. All right. Well, we'll be working on these tomorrow. Be ready to roll, guys. See you then.